Good afternoon, everyone. In this lecture, we will discuss three-phase synchronous generator, also called as the alternator. The working principle of alternator is electromagnetic induction, Faraday's law of electromagnetic induction. That is, E is equals to d phi by dt. Whenever the flux associated with the conductor changes, an EMF will induce inside the conductor. That is electromagnetic induction principle. So this principle is similar to a DC generator, but only difference is that in an alternator, the conductors are stationary and field is rotating. Now why we have kept our field is rotating over a stationary armature that we have discussed in our previous lecture. Now to understand the working principle of an alternator, we are considering our conductor is rotating but field is stationary. Okay, only for understanding purpose. Now we will start the working principle of alternator. See, in a figure A, we are having two pole alternators, N pole and S pole. So because of this N pole and S pole, the magnetic lines of forces will establish. That lines of forces will start from N pole and goes to S pole. Now in that magnetic field, a conductor is moving. A single conductor is moving. Now observe a position number 1. At position number 1, the velocity component of the conductor is exactly parallel to the flux lines. Okay. So velocity component is going upward and flux lines are also parallel. Flux lines are coming from N pole to S pole. So they are exactly parallel to each other. So there is no cutting of flux due to this velocity component. So EMF induced will be 0 as there is no flux cutting. D phi by dt is equals to 0. So EMF E is also 0 inside the conductor at position 1. Now this conductor start moving slowly towards the position 2. As it start moving from position 1 to position 2, the number of flux lines cut by the conductor start increasing slowly and up to a position 2 it will cut the maximum flux lines in the pole region N. Okay. So if you observe the position number 2, now the velocity component is going to the left hand side, so that velocity component V is exactly perpendicular to the direction of magnetic flux lines. Okay, so at this position the maximum flux lines are getting cut by the velocity component V and maximum EMF will induce inside a conductor. Now again from position 2 to position 3, the number of flux lines cut by the conductor starts decreasing and it will come to position 3. Now at position 3, if you observe, the velocity component is exactly vertical coming downward. Okay. Now again the velocity component V is exactly parallel with the flux lines direction, and in at the position 3 the EMF induced will be 0. Then again from position 3 to position 4, flux lines number of flux lines cut by the velocity component start increasing, and at position 4 there will be the maximum flux lines cut by this conductor. Okay. So at position 4 again the EMF induced inside the conductor is maximum. But if you observe at position 2, the direction of velocity component is to the left side, and at position 4, the direction of velocity component is to right side. So the polarity of the EMF induced at position 2 and position 4 will be exactly opposite. Now again from position 4 to position 1, if we move our conductor, the number of flux lines cut by the conductor start decreasing, and at point 1 it again becomes a 0. Now observe this waveform. Now for position 1 the EMF induced is 0, so that's why our waveform will start with the 0 at position 1. Then at position 2 it will become a maximum when velocity component is exactly perpendicular to the flux lines. Then at position 3, see, Again from 2 to 3 it starts decreasing, and at 3 the velocity component is exactly parallel to the number of flux lines, and that's why again EMF induced is 0 at 3. Then at 4 the EMF induced is maximum but in opposite direction. So in a N pole we have got the positive polarity, and in S pole at position 4 we have got negative polarity. And again further we move our conductor up to position 1, the EMF will be 0. So now listen carefully. For one mechanical revolution of our conductor, we have got one electrical cycle of EMF generated. This is in case of two pole alternator. Okay. Now what if we have four pole alternator? Now see in this figure we have four pole alternator: N pole, S pole, N pole and S pole. Okay. Now again start from position 1. Now at position 1 if you observe closely, the number of flux lines coming in the contact with the conductors are 0. So EMF induced is also 0. Now from position 1 conductor starts moving towards position 2. Now when it comes to position 2, the maximum number of fluxes or maximum number of flux lines are getting cut by this conductor. So EMF induced is also maximum. Now from position 2 to 3, again the flux lines cut by the conductor start decreasing. At position 3 it will be 0. Then when it comes to position number 4, again it start increasing. At position 4 it will be maximum. At position 5 it will be 0. Then again start increasing. At position 6 it will be maximum. Then again start decreasing. At position 7 it will be minimum, that 0. Okay. Then again start increasing. At a position at 8 it will be maximum. Okay. And then at position 1 it will be 0. Now observe the waveform. We have started with the position 1, therefore their EMF is 0. Then at position 2 it will be maximum. Then at position 3 it will be 0 again. Then at position 4 it will be maximum but in opposite direction. Then at 5 it will be 0. Then at 6 it will be positive. 7 it will be 0. 8 it will be positive. Sorry, it will be maximum but in opposite direction, that is negative. And at 1 it will be 0. So what we have observed here, for N pole we have got positive polarities. Position 2 and position 6 we have got positive polarity, and position 4 and position 8 we have got negative polarity for S pole. Okay. But now for one complete mechanical revolution, now try to understand, for 4 pole alternator, to complete a one mechanical revolution we have completed 2 electrical cycles of EMF. Okay. So as the number of poles are increasing in case of alternator, with the one mechanical revolution, the electrical cycles of EMF what we have got, the number of electrical cycles are increasing. Okay. Now what is the formula for that we will discuss. Now first we will discuss this working principle in detail. Now see. At position 1, this we have already discussed, but just we are going through the slides. At this instant, the entire velocity component is parallel to the flux lines, and hence there is no cutting of flux lines. Hence d phi by dt at the instant 1 is a 0, and hence the induced EMF in the conductor is also 0, as we have already discussed in case of two-pole alternator. Now as our conductor moves from position 1 towards the position 2, the part of velocity component becomes perpendicular to the flux lines, and proportional to that EMF is get induced inside the conductor. So at position 2 the EMF induced is the maximum. See, at position 2 the entire velocity component is perpendicular to flux lines. Okay, and hence EMF induced is a maximum. Then again from position 2 to position 3, the number of flux lines are getting reduced. See, at position 3 the velocity component is again parallel to the flux lines, and hence EMF induced is 0. Why it is 0? Because from 2 to 3, the velocity component is perpendicular to the flux lines. Okay, and it starts decreasing, and it starts decreasing, and hence induced EMF magnitude starts decreasing. Okay, now at position 4, as conductor moves from position 3 towards position 4, the velocity component is perpendicular to the flux lines again start increasing. Okay, but the direction of velocity component existing during this movement of a conductor from position 1 to position 2 in opposite direction. Hence the induced EMF in the conductor increases but in opposite direction. Okay, so this is the explanation um, of working in case of 2 pole. The same explanation we can write for the 4 pole also, as we have discussed. Now we have then after that we have discussed mechanical and electrical angle. Now for 2 pole alternators, one complete revolution of a conductor will induce the EMF. The EMF will experience twice the maxima and 2 times the zero. See, for 4 pole For 4 pole alternator with the one mechanical revolution, we have experienced 2 times the maxima and 2 times 0. So maxima we have experienced at point 2 and point 4, and 0 we have experienced at point 3 and point 1 again. Okay, after 4 that point will come, at 1 point will come, at that point we have experienced 0. But in case of a 4 pole alternator, for one complete mechanical revolution of a conductor, the induced EMF will experience 4 times maxima and 4 times 0. Now see here, we have experienced 4 times maxima at 2, 4, 6 and 8, and 4 times 0 at 3, 5, 7 and 1. Okay, so for 4 pole alternators we can write 360-degree mechanical is equals to 720-degree electrical. Okay, so we have one general relation between electrical and mechanical degrees as 360-degree mechanical is equals to 360 degree into P by 2 of electrical. Now we have 4 pole alternator. Now put the P4. So 4 by 2 will be 2, and 2 multiplied by 360 will be 720. So for 4 pole alternator, for one mechanical revolution, that is 360-degree mechanical revolution, we have got 720-degree electrical revolution. Now if we have 6 pole, or if we have 8 pole of alternator, so at P there will be 8. So 8 by 2 it will be 4, and 4 into 360, then we will got 140 degree of electrical revolution. So generally if 360 we have cancelled, we have got 1 degree mechanical is equals to P by 2 degree electrical. Okay, so this is the complete explanation about the working principle of alternator. In the next lecture we will discuss the frequency of induced EMF, then working principle of alternator. Inside we will discuss the synchronous speed and the frequency of induced EMF. Thank you.